Welcome back. Good afternoon to everyone. We'll start slowly the time everyone can join their seats. I'm Julien Villalongue. I'm the managing director of Leonard. It's a pleasure to host this day every year now. This Paris Summit day at Leonard in the Vinci Day. So I will give you a bit of overview of the afternoon before introducing our panelists and to host this panel. The time for everyone to join us. So we'll have two sessions at the beginning of this afternoon. One remote session just after this one. And then we'll have a conclusion, some insights by Vinci's EVP of development, and then we'll have the demo day, the presentation of the different startups supported by Leonard this year. So I think we started to be a bit more numerous in this auditorium. So let me introduce this session, this panel, in the context of energy transition. We need to produce more electricity. Of course, we are, I think, all committed to the development of renewable energy, but there is a rising interest in nuclear energy, and with also innovation in this kind of production. I think I have a slide. Maybe I can show you some. Okay, so. So I've selected a piece of highlights news from the last week's month, showing that there is huge commitment in development of new reactors and development also increasing of nuclear production. You have some example on this slide in Europe, but also in North America. And there is also a strong rising interest by big tech companies with the development of AI and the energy needs for data centers and hyperscalers. In this context, we have the development of traditional reactors, traditional nuclear reactors, but we also have new kind of reactors, what we call small modular reactors, and this is the topic of this panel. And I'm quite confident that our panelists, our great panelists of this afternoon, will help us to understand what we are talking about and what are the industrial paths for the development of these new reactors. But maybe to get a bit into details what we are talking about, we're talking about small modular reactors. So it's basically 3 letters, summing up what are these kind of reactors. So we are talking about small reactors with a power range, electricity power range between 20 and 300 megawatt for SMRs. They are designed to be modular, designed to be factory manufactured, but also you can allow the addition of numerous units of these reactors. And of course, we are talking about reactors, nuclear electricity production reactors. Behind this concept, there is also an industrial pledge, and I hope that our panelists will be able to confirm or invalidate this industrial pledge to be able to build more simplified, standardized reactor, to have project with secure costs and schedules. And you can have some example in mind about difficulties in developing new nuclear reactors with these challenges in mind. Of course, we are talking about the need of supply of low carbon green electricity for the customers, for the industries. and like we want like to be able to have cost control about that. So to talk about that, I'm really happy like to welcome Roland Frack on stage. You're the Chief Strategy and Financial Officer of Nuward. Nuward is a spin-off of EDF, which wants to leverage the track record and expertise of the group to develop SMRs, a new type of smaller reactors, and to help like accelerate the decarbonization of the electricity, the industry, and urban heat. And joining us also, Florence Laizier, welcome. You're the Managing Director of Dodin Campenon Bernard in the Vinci Construction subsidiary, developing know-how and expertise in the construction of this new nuclear value chain. Welcome, and I think we can applaud them to start this conversation. You will have the opportunity like to ask some questions at the end of the session, so do not hesitate at the end like to raise your hand and ask questions to our panelists. But I'll have the advantage of asking you maybe, Roland, the first question. So I gave like a very short introduction about SMR, but maybe you can elaborate on the specific advantages that SMRs offer, maybe compared to traditional larger reactors, and maybe also like to help us understand what are the market segments you want to address with these kind of reactors.
Thank you, Julien, and hello, everybody. Your introduction was very good. In one word, what SMRs do compared to large-scale reactors? It enlarges the market. Today, you can use nuclear only in very specific application because it is big utilities, more or less 1 gigawatt, and you need a strong network, and most of the time you only produce electricity because you are far from the consumption places, and it is difficult to transport heat along the way because you lose energy. So SMR enlarge the market because you can install them first in places where the network is less robust. For example, on an island, for example, in remote areas, for example, in Canada. OPG was listed on the slide behind. Canada is a very large country, and in some places it's advantageous to have local production. It enlarges the market as well because, as you maybe know, I'm sure you know, a nuclear reactor do not produce only electricity. It produces heat first, and then convert it to electricity. With a efficiency ratio 3 to 1, you lose 2/3 of the energy. So it's very interesting to use heat, but heat is difficult to transport, and SMR, because they are small, can be installed near the consumption places, and it's an advantage. A few words of definition to add what you begin to do. SMRs are very broad spectrum of technology and size. It started from few megawatts for very local application. For example, X Energy is producing a reactor for the US Army, where you can replace a diesel engine, for example, up to 300 or 400 megawatts. Like Nuward or a reactor. So, and the technology can be very wide range of technology. It can be fission, as you said, as usual, PWR, BWR, so it's technical words to say the reactor we know today, so the same physics, pressurized water reactor, boiling water reactor. It can be more evolutive technology with very interesting pledges, but which will arrive later, it's what we think, 2040, because we need research, an industrial plan for the fuel, which is quite long to put in place. So it's a very broad range of technology and sizes. And what makes, and I will end by this about the specifics of SMRs. How do you choose about size and technology? You have two trade-offs to do today with SMRs. The first trade-off is size versus series effect. When you lower the size, you can industrialize construction. And this is what we try to do with SMRs, industrialize construction. Nuclear is one of the economic domain where, and like construction, where we did not benefit from the efficiency all the other industrial, manufacturing industrial sectors like automotive or aerospace benefited. We don't produce in series, and we must do it. So you reduce in size. But doing that, you lose the scale effect, because the bigger your plant is, well, the easier it is to amortize the fixed costs. So you have a first trade-off. The second trade-off is technology versus time to market. Today, as everybody knows, we must more or less multiply by 7 the decarbonized electricity power generation in the world in 2050. So in 2050, in 25 years. In 25 years, we have to multiply by 7, from 10,000 terawatt-hours to 70,000 terawatt-hours of clean electricity production. That's huge. So we must be quick. And you have the trade-off to select between a technology which is not mature instead of using a technology which is here already. And it's what we do at Nuward. Nuward is business at EDF. A few words about our technology. It's a 400 megawatt pressure water reactor. So it's the same technology that we use today in our large plants. But in reducing the size, we can modularize our systems and manufacture them in a factory. And we are looking for partners with other players. That's why we spinned off to innovate, not in the technology itself, but in the way we manufacture and the way we build these plants in a very efficient way to lower the risk and then lower the cost of capital and then reduce the costs.
Among these partners, I assume that there is like construction companies. So maybe like that's a question for you, Florence. How does VINCI Construction like see this rise in summer, like this time to market, this needs of like new plants, and how do you plan to address maybe this like changing market and all the challenges that we have been talking so far?
Thank you for the question, and hello to everyone first. I fully agree with what Roland said. It will be a change in the market, and in VINCI Construction we see it, or I see it, as a true opportunity to improve our energy and the fact that it's a clean energy. We can't only count on a only source of power in terms of clean energy. We will of course have renewable energies like wind or like solar power, for example, but they are intermittent. So we are convinced that we need nuclear energy in order to be a kind of backbone, in fact, for this intermittent energy, and of course nuclear power can provide this backbone. But specifically for the construction, it's an industrial project. So we need to tackle with this kind of difficulties or this kind of challenges of an industrial project, and in that way we will. I think it will be a kind of accelerator of industrial deployment of our way to construct, because we need to have several partners, and exactly what you said, that we need long-term partnership, in fact, between different players from all the supply chain, including constructors, in order to create this kind of project. And at the end, we need to change a little bit the way we contract this kind of project. And maybe to go a little bit more in the decarbonization you spoke about. This is also a way for us to decarbonize our supply chain, because if you take what you use in construction, we use concrete, we use cement, we use steel, for example, and it's our main source of carbon. And this kind of course, we work on how we can decarbonize our supply chain. We are searching for different binders, for example, for concrete, and how to have a lower carbon weight. But one solution will be also carbon capture. But this kind of systems, carbon capture systems, are very need a lot of energy. And so we imagine that if you can combine, for example, SMR and carbon capture systems for the production of the cement, it will help us to decarbonize our supply chain. So we see a lot of opportunities in SMR in a way for our business, because we think it will be a new product and a new way to construct. So we need to be involved in that new product, but also in order to help us to decarbonize our supply chain.
Thank you very much. So we're talking a lot about like industrialization and the need like to spread this kind of reactors. Also, you mentioned like the cross 7 times, like to tackle to meet our goal. What are the main challenges you can see like in this like process of industrialization and widespread of this kind of reactors in the market?
Yes, it's a core point of the SMR's challenge. It's what we look for, industrialization, and there is a way to achieve this goal. Before answering your question, just a few words about the applications, because I did not precisely answer your question about segments, and we talked about CO2. It's a good example, just to highlight the interest of producing electricity and heat together in a local place. With electricity and heat, you can produce low carbon hydrogen with a higher efficiency than if you have only electricity. With high temperature electrolysis, it's a process to manufacture, to produce hydrogen very efficiently and with very low cost. You can, of course, use it for industrial process, for urban application as well, and desalination. It's another example where electricity and heat allows to gain efficiency, cost, on producing what will be very precious in the coming years, desalined water, pure water, with a low carbon production. And indeed, this industrialization is for this goal of being a couteau suisse. So I looked for the translation in ChatGPT. I heard Swiss Army knife, so couteau suisse, energy transition couteau suisse. So industrialization, I think three things to fix to achieve this industrialization. First, if you have to have a ready supply chain, it can be obvious, but if you don't have a supply chain today which is capable of building your equipments, you go nowhere. You don't have the time to build a supply chain that you need for the coming years if you are focused on the net zero in 2050. It's what we have with Framatome and with the European nuclear supply chain with which EDF works every day. So this is very important. Secondly, you have to harmonize safety standards, and that's a big deal. Today, you don't have a European nuclear market. It doesn't exist. You have one market, one country. In the US, you have a large market. In Europe, it doesn't exist. The European market for goods and services doesn't work for nuclear today. So that's something we have to achieve, common rules and common licensing process, because if you have to license a new reactor in each country, you cannot have a standardized plant. And the third point is to have a design to industrialization approach as soon as possible in the design process. Today, when we design Nuward, we don't talk about physics. Yes, of course we talk about physics, about neutrons, about temperatures and pressure and thermohydraulic cycle. Okay, but we know how to do that. We have models, we click, it runs. What we have to invent is what we talked about, is how we construct in an industrial ways plants which are made of concrete. It's not steel. We know how to do modules for the oil industry, for example. It's module made of steel, made of pumps, made of valves, made of... No. We know how to do this. When you have concrete, and nuclear, we need concrete for the radiation, for the protection against fire. We need concrete, and we have to industrialize construction. And we have ideas, steel concrete, open top. We have technologies in mind, automation of... but we don't know. We're not at the cutting edge of the construction techniques, industrialization. And what we need partners to work together to improve our techniques and be able to industrialize. Because we can. The size of our plant allows to construct entire system, entire modules in the factories and to have mass series production, even if in concrete prefabrication techniques. So that's the further point we have to tackle.
Thank you very much. Maybe let's talk about enablers that can help us to be able to build these new reactors. That there is a big room for innovation, I think, from a construction and engineering perspective, from your perspective. What are the main fields of innovation you can see trying to help our Roland to build these reactors?
I think the field is quite large, in fact. The good news is that we don't come from nowhere. Just in terms of, just a figure, inside Vinci, the turnover of nuclear activities is around 800 billion per year. In a large field, in fact, from civil works to engineering, to decommissioning and waste management, for example, if we can refer to Nuvia, or to some instrumentation on and controls. So we have the ground, in fact, to innovate in that kind of field. But I was very happy to hear that you need concrete, because sometimes people who are working in SMR, they say, "Oh no, it's just a system. We'll do a little box around, but that's nothing." No, it's not nothing at all, and it has to be integrated from the beginning of the project, as you do, in fact. In order to really construct an industrial system, an industrial project, well integrated. Because the challenge is to integrate all the systems on field with projects and with piece of the system, modular systems who are already done outside, so in factories or in off-site, in fact. So the challenges we have to tackle is, of course, to be industrial in that kind of field, and to, of course, to manage our costs, our schedules, etc. But that's the way we work usually. But it will be more specific in that case, because it's an industrial project, and we need to have to be comfortable with investors, with industrial. And moreover, we have to, as I explained, we say have long-term partnerships with different players, but also with regulator. It will be a question of authorization, of regulation, and we have to build the confidence, in fact, with the whole ecosystem of the nuclear ecosystem and the SMR ecosystem. And maybe a last one. Innovation or challenge we have to tackle with is a question of people. We need people to build of this project, and we need qualified people. And one chance, or maybe one opportunity we have with SMR is that we will do a lot of things like modular system in factory or offsite, and it's a big difference with a large reactor where you have to put people on the field. For the next EPR, for example, in a large reactor in France, you will have something like 5,000 people on the field in the place where the reactor will be. In that case, we will can organize ourselves and our people in order to have qualified people off-site, in fact.
Thank you very much, Florence. Maybe we can take some questions in the audience. So if you have a question for Florence or Roland, maybe raise your hand. Okay, there is one just here. Maybe we can have a mic. Thanks.
Hi, I'm Matt Gray with BuiltWorlds. Fascinating discussion, appreciate it. You mentioned needing partners. Can you talk about any examples of partnerships or maybe how any of the companies that would be interested in partnering would go about something like that? Again, you've got an audience here from all over the world, so they might not be as familiar with how they could potentially get involved or the kinds of specific partnerships you might be looking for.
Maybe for you, Roland, about partnerships. It's a call for partners. Okay.
Thank you for the call. I was expecting the questions, and it's natural, and thank you for asking it. Today, we think that the expertise we should reinforce at EDF and in Nuward in particular are EPC project manager, how to have a real EPC complete responsibility in managing projects. We should know how to do, but I will give you a secret. Doesn't work very exactly how we would like to. So I think we have to reinforce this expertise at EDF. Second, we have to have partners specialized in construction optimization on site, because I was speaking about modularity, but it's both hand, it's both foot, both. Yeah, there's 2 points. First, factories, how to displace manufacturing in factories, and how to optimize the operation on site. And on site as well, we are not an expert. We work together with a lot of construction group experts around the world, but we still have to reinforce this expertise too. And third, manufacturing of modules. We don't know today how we can manufacture in a factory SMR modules at a large scale with a long-term partnership, because we have a high market risk on the business. We don't know how many SMRs we will sell, right? Maybe several, I don't know, the market is something about hundreds of SMRs. How we take us, if we don't know if it will realize or not. So there is a big risk, and we must find partners to construct on the long term in a real partnership. In all the manners we can find to build that partnership, to go in the long term with investment, because it will be needed to build these module factories.
Thank you very much. Is there another question in the audience? No, maybe I have one for both of you, maybe for you, Roland. Is there a consensus about, maybe let's talk about cost, is there a consensus about the cost of this kind of reactor, which can be able to make them competitive in the market, maybe in euro per megawatt or something like that? And maybe how do you see the time frame of with building this kind of reactor? When do you think, what's your assumption in making this reactor like a market reality, so time frame?
Well, market realism is a very difficult topic in energy. When I was at school, I remember something a professor told me, that in energy market, never try to see the future in prices. Well, it's true in every market, but especially in market energy. So it's very difficult for us to know what will be the good price for electricity. At what cost are we bankable? My answer will be a range. I say between 60 and 100 euros of today per megawatt hour. That should find a place on the market. You have to keep in mind that if we listen to economists to tackle these net zero 2050 challenges, CO2 should cost in 2040 several hundreds of euros per ton, several hundreds of euros per ton. So it's equivalent of 100 euros per megawatt hours just for the cost of CO2 if you have gas marginal or core marginal electricity production system. So depending on the way societies will tackle climate change, cost of CO2, subsidization of production plants, the market will be different. So it's very difficult to answer the question. We think that between 60 and 100 euros, whatever the future is, there will be a place for every mean of electricity, clean electricity production system.
And just a word, you spoke about cost, but maybe we can also speak about value, because today having a reliable energy may be vital for some industries. So for them, and we see in data centers, for example, they are totally keen to buy some SMRs just to be sure to have access to reliable energy, just for that. And this kind, we can say that it has no cost. It has a huge value, in fact. And so they are totally ready to pay the price in order to have this reliable energy.
I propose to leave you with this consideration about value and electricity. Thanks again, Florence. Thanks again, Roland. I think we can give them a big round of applause.